I think it's 2:20, so I better kick on. I've just seen the number of slides I've got, so I might have to skip a couple. Okay, so the talk I'm going to be doing is about Ansible, a lean approach to server provisioning. So broadly speaking, I'm going to run through what is server provisioning, why it would help you in a lean environment, what advantages does it bring, and then for the latter half, I'm going to focus on one of the tools you might choose to use, which is Ansible. It's something I've picked up recently in the last year. Even going to run for some real code, actual code samples. You don't need to understand them. You won't let them breeze over you, but hopefully it will show you how little work is actually required to get up and running with this tool and trying it out for yourself. So next, the obligatory last conference slide. We thank all our sponsors, which obviously no one else used, but we were asked to use it, so I've used it. Econex, one of the sponsors also who I work for, as a few people in the crowd already know. We are a building software engineering company. Jack's there knows a lot more about it, so you can talk to him afterwards. Who I am is far more important. My name's Bento, Phantom Whale on Twitter. That's a younger me without so much beard. But server provisioning, before we got it, has driven me to grow this facial hair in the horrors it schools me. Anyway, so the story so far. So this is setting the scene. This is where we were, I'd say, about a year and a half ago now. We've an app. It's a single app. It runs on the cloud. There's just a single server. It's running some Ruby on Rails. Fantastic stuff. And it was going fine, except we need to do an operating system upgrade. Apparently, Ubuntu, I think it was 10, was getting a little bit old, so we need to do an upgrade, and we thought, this won't be too hard. And it was at that point we discovered that we didn't just have a server running Ruby on Rails, we had a server running Ruby on Rails, which also happened to have an Apache web server to serve up our stuff, and oh yeah, we've got an Elasticsearch thing that helps us search some documents, which we got stored there, and of course there's users on the server, and those users have roles, so we have to set all that up. Oh yeah, and there's an email queue, because you've got to send emails. Oh, and there's scheduled tasks as well, and there's SSH keys, and the various credentials. Actually, it turns out there's a heck of a lot on our server. Fortunately, all that information was available in the form of Fred. Fred was our developer. He knew all this stuff. He knew it intimately, so we had nothing to fear, really, except there are 3 natural enemies to Fred out there. Money. Someone might pay Fred a bit more, and then he'd leave us. The dreaded number 73 bus, which could strike anyone at any time. And finally, Fred might just simply forget. And we were definitely towards the latter half of those as we kind of scrambled to try and come up with the details, work out what was missing. The obvious approach, which we had done partially, was to document all the things. We had 2 or 3 wiki pages, various information, little chunks of scripts we can run. Oh, don't forget to install this, except no instructions on how to install this. But primarily, we thought we had everything documented. But as we discovered, documentation, there's a lie waiting to happen. There's various assumptions built in. People had put stuff on, forgotten to document it. New things are coming which won't run in order anymore. Essentially, we had a kind of wish list on how it might go, but the documentation we had was useless for recreating the server. So what this leads to in practice, if you keep this kind of manual or just sort of wiki page of documentation, is you end up with what Martin Fowler has called a Snowflake server, which is unique, it's beautiful, it's individual, it sparkles, does everything it needs to do, but it's utterly impossible to create another one exactly the same ever again. And that was the situation we had. We had our production server, and no one had a clue how to make exactly the same one again. So we had to kind of take a step back and find a better solution. So we had a look at server provisioning. So briefly, in case people aren't aware, the reason we look at server provisioning, so this is tools that help you get these servers up and running using scripts or just sort of configuration to make sure that every time you run these scripts configuration, you end up with exactly the same server, exactly the same Snowflake every time. And the ideals behind it is previously we used to teach our servers like pets. Beautiful, lovely Shep there, lovely dog. We look after Shep. When Shep gets ill, we get him medicine. And we should stop doing that, and we should start treating them like cattle, which is if old Bessie Bear's getting a bit sick, we can always get a new cat. So, because we love our dogs, but we wear our cows. If your cows keep getting sick, you probably need to look into that. But broadly speaking, if one server's just a bit troublesome, you want to get rid of it, you can just spin up a new one with server provisioning. There are 4 big names in the provisioning world. Puppet and Chef are normally the ones people have heard of. We certainly dabbled a little bit with Chef, being Rubyists. Rubyists tend towards Chef. And there was already some Puppet in the rest of the organisation. I've never played with Puppet. I don't know how good it is. I spoke to some people who had used Puppet. and I decided to use Ansible after talking to him. So I don't know much about the others. All I do know is Puppet and Chef certainly have got, I think, the market share still, although Ansible's catching up. They tend to maybe have some older concepts that Ansible doesn't use, stuff I'll sort of come on to. So the rest of this talk is basically looking at Ansible. What is it? What does it do? How does it create servers for you? And if you follow along the code examples, I'm going to go through them fairly quickly, but if you follow along, there's all the bits of code you need to get a server up and running in the next 22 minutes, possibly less. So if you want Ansible, it's normally a one-liner to install. This is how you'd install it on a Mac, but it doesn't matter if you're on a Windows machine or a Linux machine, there's going to be a one-liner somewhere. And that gets you the Ansible tool on your machine. So these aren't the servers you're deploying to, this is your machine where you're going to kind of drive this process from. For the servers you're going to deploy to, now with other systems, you might need a kind of Puppet client or a Chef client. I know the Chef solo, but with Ansible, all you need on the other machine is SSH. And for the less technical people, everything pretty much has SSH on it these days. That just is a mechanism for Ansible to securely log in and run its commands remotely. So this is one of the selling points of Ansible. You don't need anything. Almost every server out of the box is going to have this up, running, and enabled. There is a little bit of Python it uses as well, but you don't need to know about that. Everything's got Python on it. You can ignore that. So aside from installing Ansible, one-liner, the only other thing you'll need is an inventory file. You need to tell Ansible where are your servers. They're out there somewhere. It needs to know where they are, how to talk to them, and you do this with an inventory file. That is, broadly speaking, looks like this. You have kind of groups of things. So I've got my web servers, my databases, and I've got a group called primary, which is probably my primary web server, my primary database. And then, yeah, you list the servers underneath. So it's just a simple list of addresses to where your servers are. And once you've got this, you're ready to go up and running. The first thing you might want to do with Ansible before you go and try and write your big grand script to recreate your server, certainly what we did just for an hour or so, see how it works, see what it does, is you just want to run it from the command line. So again, those of you who are less technical, command line shouldn't be too scary, but I think these examples hopefully speak for themselves. The very first command you might want to run is ping. So this is just saying Ansible, so Ansible is just the command. Ansible all, which is all the servers in your inventory file. I want to run the ping module. And that simply says, hey, can I talk to you? Have I got my connect? Is there a firewall blocking me? Just check I can actually talk. And hopefully you'll get this sort of reply saying, yeah, got it, saw it, we're ready to go now. Once you've pinged, which you can do for hours, it's great. But there are better things you should be doing. The next thing you might want to do is just play with command. Command literally just runs a remote command on the machine, just to see how it works. And so there's a command module, and you're kind of passing these arguments. So sbin reboot, for those who don't Unix, reboots the machine. It's not an incredibly useful command, but it can be handy at times. So popular is the command module, you actually don't need to specify it. You just feed it in like that, and it knows you meant, I'll run a remote command for you. If you can't connect, there's a bunch of connectivity options. Again, you'll get these off the manual page, but this just shows, you might think, oh, but our server's a bit funny, it's got difference, you have to log in as this guy, then you have to change to this guy. Ansible's got you covered. You can log in as whatever user you like, you can sudo up to the God permission to root, so you can do anything you need. You can get it to interactively ask for passwords, or you're probably more likely to be using SSH keys, so you can do this without passwords. So there's an example where you're using the bwayne user to log into your server, but once you're logged in, you're going to sudo up to a different user, in this case Batman, who's going to do all your work for you. So that's fiddling around on the command line. You've got it up and running, you've run a couple of commands. Now you're ready to start looking at kind of what does Ansible offer you. I mean, running remote commands isn't very impressive on its own. So here's an example again. Don't worry if you don't know the Unix foo on all this. This is simply adding a user called admin user, putting him in a group called admins, and then, creating a group called admins and then putting a user in the group. Just some basic kind of user group permission stuff you'll probably need. And when you run that, brilliant, success, great, that works fine. And then you try and run that again later in the future, and suddenly you get failure, success. And that's because you're just running remote Unix commands. And those Unix commands are going, well, you've already got a user called admin user. I can't create this. I'm going to throw an error. And similarly, the group ad says, no, you've got this group. I'm not going to do this for you. So this is not very useful. The idea of these scripts should be repeatable. You should be able to run them over and over again to keep your systems up to date. So Ansible has other modules beyond just running remote commands. In this case, there's a group and a user module. And all you're saying here is, can you make sure there's a group with a name of admins, and could you make sure I've got a user called admin user who's in that group? I don't care how you do it, just do it. And Ansible will go ahead and do it, and actually returns a little bit of extra information, which might be handy later in your script, tells you the ID of these things. But interestingly, at the top, it tells you, yeah, I've changed that, it's true, I've created that. If you run that again, you'll get the same response, but it will just say changed false. So it says, yeah, no, the group's already there, I don't need to do anything for you. This is just one example, but this shows you how Ansible modules work. You're not saying, please run this command. You're saying, just please make sure you're in this state. I just need this thing to be present. If it's already there, brilliant, just carry on. It's not a problem. And again, so I suppose the second selling point of Ansible, the first one being it's simple, you can run it against any system. The second one is the list of modules, and these are core modules. You don't need to go away and go, oh, I'll install Ansible database stuff, I'll install Ansible packaging stuff or monitoring stuff. This all comes in the box. As soon as you've installed Ansible, you've got everything here. So there's stuff to help you manage your cloud servers, manage your databases, manipulate files, config files, that sort of thing. You can throw messages around if other systems need to react to things coming on board. Packaging to install software is fairly common one. Source control, you might pull some things out of GitHub or to install on your machine. Almost everything. I've not actually found a situation where a module hasn't already been created for the task I want to do. And I've missed out a couple of slides, which I've put in a more technical version to talk about how you can even create your own modules, but there are mechanisms and ways to do that out there. So at this point, you've got Ansible, you've got it running a command line, played with a couple of modules. Now it's time to do the script, or in this case, they call them playbooks. It's some sort of sports metaphor. I don't really follow the sports balling, but I believe a playbook is supposed to be a list of plays that help you build your server. So as the straight out of the documentation, if the modules are the tools that build the server, then the playbooks are your design plans. They're written in a language called YAML. It's yet another markup language. If you haven't seen it, it's a very simple. Think if you know XML, it's like the opposite of that. It's quite pleasant to look at. And it is intended to be configuration, not programming. So you shouldn't be finding that if this, then do this, else this. And it should just be, please can I have a system with Apache on it, and I'd quite like Elasticsearch. I don't know how you do that, but just go away and do it, please. And like I say, it consists of one or more plays. And to run it, there's two command line tools. There's Ansible to do the just one-off commands, and Ansible Playbook. You feed it that YAML file, and it goes off and does the stuff. So here is an example playbook. That is YAML. You don't need to. I'm going to run through these sections very briefly, but that is something that will essentially install on the Apache web server and make sure it's been nicely rebooted, so it's got the latest configuration file. So there's three sections on that file that are broadly interesting. There's tasks, variables, and handlers. So we'll have a quick look at those in turn. This is a task. This is a thing that's going to go off and make sure I've installed Apache using the APT. apt is a Unix packaging system just for installing software. So this is go get me the Apache 2 package and make sure I've got the latest version installed. And this is actually analogous to the command line. So you've got the apt module with the arguments. You could actually run that on the command line with the other syntax there. So that's going to essentially, those are tasks, those make sure things are being run. You've got variables. This is just a way of making sure you don't hard code the same value throughout your code. So here I've got an Elasticsearch heap size, ES heap size of 4 gig, and I'm going to use that later on to put it into some config file. And you might reuse that in various places. So it just lets you declare variables at the top, and then they get fed down and plonked into place where they're needed. Variables you can define in Playbooks. Normally you wouldn't. That seems it's a nice way of extracting common values, a little redundant, but you can start to play around with variables and say, actually, for these two hosts, they're my dev machines. I can't afford 4 gig. They're tiny machines. I just want to give them 1 gigabyte of memory because they're not going to survive 4 gigabyte. They're going to fall over. And you can even extract that out further and say, anything in the small group, just make sure they've got 1 gigabyte. I don't want to, so I can just put everything in my small group and they'll get these kind of common variables. So this helps you manage machines of different sizes, different architectures, and make sure something's going to run on them. The third and final thing you'll see is handlers. Handlers are fairly simple. You might have a task. This task adds a new config file in, and at the end it goes, I need you to restart your web server, but you don't have to restart now. Just make sure you've done it by the end of the run, because otherwise stuff's not going to happen. So it just requests notify, could you restart Apache by the end? And then later on we have a handler to tell it how do you restart Apache? In this case, it just goes to the services and restarts a service, which is a fairly standard way of restarting services in Unix. I keep mentioning Unix. As a brief aside, there is vastly increased Windows support coming in the new version. It obviously wasn't the biggest demand they've had, but I think the latest Ansible is really focusing on getting the same sort of stuff, but in the Windows language. So there'll be a new set of modules, no doubt, around Windows-specific stuff. So, putting it all together, that's the playbook again. You go off and you run the playbook, and you get a nice output. Gather some facts, I'll mention that in a minute, and then it runs your free task, and it shows you that something's changed. So if you ran that again, you would actually see OK, and nothing's changed because nothing would have changed. It would say, oh, patch is already there, that file's already there, I don't need to do anything, we're done. So that just helps you see the progress of what's happened. You can see nothing's failed, which is great. If you find that still a bit techy, a bit ugly, fortunately Ansible loves cows. They really enjoy the cowsay module, and if you do nothing out the box, it will run with cowsay, which means pretty cows will tell you all the things that are happening in your machine, and I think that's brilliant. And you will keep seeing cow jokes and themes through their documentation. They somehow have grown in love with this tool. That's really all you need. That would get you an up-and-running web server. I've got a couple of slides on more advanced things. If you're kind of at your limit now, don't worry, you can turn off the next 2 or 3 slides. But I like to throw these out in case people want to know a little more. There's a couple of useful constructs I found early on when I had these massive long scripts that worked, but they didn't look very maintainable. One was loops. So this is just, if you ever want to install the Ruby language on a machine from source, you need to install about 27 packages in advance. So this is me doing number 1, number 2, number 3, dot, dot, dot. There is a nice looping construct where you say, do that command, and here's the item, just substitute it in each time. So it just helps you kind of bundle together very common commands where only one thing's changing between each line. Similarly, there are conditionals, which let you, whilst it is a configuration, not a programming language, so you should be saying, I'd like this, not providing these like if-else conditions. Occasionally you will say, in a certain circumstance, I don't want you to run this on machine, or I do want you to run this. So this is quite a facetious example. We've set our awesome variable to true, and when we get to that task, it's going to say, this machine is awesome, because awesome is true. A slightly more useful example, for instance, it's not that useful, but is if you want to shut down anything that's a Debian machine, which is one of the types of Linux. This will run shutdown, but only if the Ansible OS family is Debian. So if you're a Windows machine, it won't try and run that because it won't work, or maybe you only want to shut down those ones. You probably never do that particular task, but it's an example. And the only thing worth noting there is this Ansible OS family. I didn't set that variable. That wasn't me. I didn't create some sort of long variable. And that was when, back where we were running the wake-up machine, thank you. So with that gathering facts bit at the top, OK, what that was actually doing when it was gathering facts is it was pulling this stuff out. Now, again, don't worry about what a wall of text is, but you get all this for free. So Ansible goes away, it looks at the machine it's running on, and it says, hey, what architecture is running, how many processors it got, what hard disk has it got, what the hard disk is called, what the size of the hard disk, how much memory have I got. Any facet, any detail of the machine you need to pull out, it's probably got. You shouldn't be leaning too heavily on these, because again, this script should be fairly flexible. It should run across most of your machines without too much kind of tweakery and conditions, but sometimes it's been very useful. So we can actually look and say, oh, this machine's only got 1 processor. I will not run the multi-threaded version of the software. I run the single-threaded version because it's only got 1 processor anyway. So yeah, machine facts, didn't need them too early on, but later down the line, they've kind of helped keep our script more manageable across some various deployment platforms. And structure I am going to breeze through, but broadly speaking, once you've got that and you've kind of used a couple of these constructs to make your script somewhat manageable, suddenly, and this took me about 3-4 months to get into, but suddenly this is where Ansible became beautiful. So I've got my playbook, tasks, variables, handlers, and variables. You can have your variables in your playbook, you have them in your inventory, so they apply to groups of servers. And you've probably got some files that you kind of copy over, like configuration files, license files. So these are all the things you're playing with. You'll probably have something like that. The files, these templates, they'll be separate files sitting on their own. You'll have this big playbook.yaml, and you can kind of go, well, that's still a bit messy. So you take all the tasks and you put them in separate files. So ignore the actual content of this file. The point is we've changed that. We've put all our tasks into this apache.yaml file. And then back in the main playbook, all we do is we have a simple one-liner saying, hey, bring in Apache YAML. So that's nice, that's outside. Cleans it up. And you can do the same with the variables and the handlers. You can put them in separate files and bring them in. So what, you've kind of moved them, but it's keeping your playbook smaller. And then, again, all those variables you put in your inventory, so the variables that say, oh, all my small machines need 1 gig, you can actually move them off to separate files. And there's a sort of naming standard. If you've called the group var small at the bottom there, it knows, I am the variables for the small thing. So if you name your files correctly, you don't need to, you can really cut down on that. Anyway, you can move them off separate files. So I did this, move stuff out to separate files. It still looks a bit messy, but now I've got mess spread across lots of files. That's not helping. And roles. Roles was the secret. I can't believe you love that. Roles was the secret sauce here. So basically, roles, as they say in the documentation, are a way of automatically loading certain variables, tasks, handlers based on known file structure. Or put more interestingly, that's what I've kind of ended up with. I've pulled some bits out, and I've got my playbook at the top, just importing all that stuff. If you kind of slide it over a bit, and you create this roles directory, and you rename a few files, some of them become main, which is a naming standard, and you name a directory. If you kind of move to that structure, which only involves a little rename and a move around a couple of files, you've now created what's called a role. And Ansible just understands that structure. It knows when you say roles Apache, this is a role called Apache. And it knows to look under tasks main.yaml, except that's the default setting for where you're going to run your tasks. So if you actually move your structure over to there, then suddenly your playbook looks like that. You're saying, I've got a server, put Apache on it. So you've made bigger building blocks. So you've played with a little Lego and you've made something nice. Now you're playing with big blocks of Lego because you've just produced your role. You can put it there. And then you can start moving up to this. So this is I think, mostly based on our real server. We have a common role, something every server gets. Someone installs Java, someone installs Elasticsearch, someone installs Ruby. And they're big building blocks. If I want to put Ruby on another server, I can just take my Ruby module, Ruby role and put it over there. I can take my Java role and put it over there. And broadly speaking, these should be sort of reusable artifacts. So once you got there, and like I say, this was 3 to 6 months down the line for us, just kind of getting to the basic playbook gave us plenty of functionality over having our manual script we had to run every time. But once we got to this point, we were now ready to really sort of manage this and sort of keep expanding on it. All the code was nicely compartmentalized. It was easy to work in parallel on it. And we found a few good tips, which are also, these are Ansible recommended standards. You always have a thing called site.yaml. That's the thing that talks about everything in your entire architecture. We only have one server, but when you get to several servers, you'll want this site.yaml, and you can just kick that off, and it does everything. We haven't really moved on to that yet. Really important is to keep your inventory files separate. Have a production one and a not production one, because I'm not saying that I ran our script against production when I meant I was testing something, but it could have happened, and that would have been a bad thing. So I highly recommend doing this. If you want to kind of override settings for maybe certain servers need less memory for something or a different version of something, you can put them in named files, which is a good way of putting them. And everything else needs to go into these roles, which keeps everything nice and separate, nice and clean. It makes it clear what's doing which, what's doing what. So why am I doing this talk as a Lean Agile Systems Thinking Conference? Broadly speaking, because although obviously I've condensed knowledge of 6 months into about 20 minutes, that is literally all you need to get, I reckon, some pretty kick-ass server provisioning going in your environment. There's not a lot of ops concerns or architectural concerns around it. It's quite easy to put in place. And there are several other resources you can go to help you get up and running quickly if this is something you want to try or experiment with yourself. Before I list those resources, look at the ThoughtWorks radar, the oracle into the future. And ThoughtWorks pulled out Ansible. This is a few months old now. And they said in the category of DevOps orchestration engines, Ansible has nearly universal acclaim within ThoughtWorks as useful tools and abstractions to a useful level of granularity. So I think they quite like it as well. Why would I recommend it? The documentation is great. It's really clear, really concise and nicely laid out. They update the software every 1 to 2 months. They update the documentation every 1 to 2 months. It is live. It is it's fantastic read, and it highlights when new stuff's happened. If you're really, really keen, you can subscribe. They love cows. You can subscribe to the Ansible weekly newsletter. This normally has a couple of blog articles, maybe a video, and lists any Ansible talks going on. I get very excited when I see there's a talk in Australia. It's always mine, but I'm hoping one day it won't be. And the other resource, mixed reactions to it so far, but allegedly for these roles, these big reusable blocks, you can publish your roles up to Ansible Galaxy, which in theory you should be able to go there, and I think similar to Chef cookbooks, and there's probably a Puppet equivalent, you can pull down just a ready-to-go role. So I need Ruby on the server, as a Ruby role chunk. For some things, that's been incredibly valuable. I think there are some pretty hokey bits of code up there, so like getting stuff off GitHub, look around, see how much work's been done on it, see how many people are giving it thumbs up. But I think there's some useful assets to share up there. And broadly speaking, that is my 25-minute rushed introduction to Ansible. Thank you. And I think technically I have 2 minutes of any questions. Gentleman in front row.
How do they recommend that you share the roles? Like, do they say check out your repository? Is it like Python X?
Currently, obviously in the broader kind of with other people and other teams, it would be the Ansible Galaxy. That's what I recommend. Within your application, there's no recommended packaging of the roles, putting them in a zip file or anything. No, they just sit there in your repository. I think the idea is you would drive maybe the machines for most of your enterprise out of the same repository. You've got this site YAML which talks about the web servers and databases, and you kind of, when you run it, you specify, I just want to set up the web servers for this project today, and it'll pull down the roles it needs. I think the idea is they're all in the same repository. But again, we played at a very small scale, so I'm not quite sure.
So I just noticed something. Actually, all these Puppet, Chef, Ansible, all they keep going because I'm actually building quite an integrated tool as a startup. These guys have been using Ansible for over a month, so they should basically go like. But the funny thing is, so all the stuff you said there, I mean, getting Puppets and Chef like the same. One of the things that I think Ansible is missing out when you go to the facts and that sort of stuff, it's around the CNC thing. And when you get to a bigger environment, I'm interested in how it can be done with the Ansible space. When you're actually going out there and obviously getting those maps back to the degree, where are you storing it? What are you doing with them? Are you putting it into your own CMDB, or how big is the system? So in a startup sort of area, it's 4 or 5, 6 systems, people don't really care, and they just, they use it like the cow sort of thing, like you just go shoot it later.
Yeah.
Sorry. But it's more so in the bigger environments when you start getting into the enterprise side of things, say 1,000 machines and that sort of stuff. It's when you try and look across those machines and say, what's different?
Right.
When was that updated? How many of these packages are out of date, and is that only in production or is that in those environments? So Puppet has Puppet DB, which is a huge enterprise thing, which makes them a lot of money. And Chef is similar in the way that they have got their online SaaS service. Wondering what you've done with it in the Ansible perspective.
Not a heck of a lot. I mean, the machine facts themselves, I believe you just use them kind of on the
run.
On a run with Chef. You don't store them off anywhere. There is, I don't know if it's quite answering your question, there is a thing, Ansible Vault now, which I think is their attempt at having somewhere where more you could put, I think that's more for where you put your secret keys. At the moment, I'm not saying we have, but we may have a couple of passwords encoded in our Ansible. Thank you. Nothing too production serious. They're in the other Git repo. But yeah, so there is the idea of Vault store sort of secrets that machines would need. But yeah, otherwise, like I say, I've only really had experience with 1 or 2 machines. It seems to work fantastic. We've certainly got script now. We haven't actually got to the cattle stage because we're only a single server. We can't kill Bessie. It's the only milk-producing cow on the farm. So we could spin up a separate cow. The metaphor's failed now. But there's got to be a certain period of downtime for us. So where we can, we try and run the same script on the same machine over and over, and it works. It's very good with this. The ideal I mentioned, where it's idempotent. It doesn't matter if you run it 1 or 100 times, it'll put it in the state it should be in and not do anything unexpected.
I thought it was good. I think you wrote some protocols as well. If you've noticed now that Ansible did that, Puppets playing catch up, in November they were releasing lots of protocols as the only way you can build machines.
Right. Okay.
So,
fair enough. Brilliant. Thank you very much.